right? But when we talk about polarity, ignore the distortions, so just think of the ideal angles. Ideally, this bond and this bond are opposite, the axials are opposite, cancel each other. But here, these two are in a bent, they're pointing like this, nothing opposite of them, so this molecule is polar in this direction here. So the fact that all 5 positions are not occupied by the same atom, it makes it polar, right? But having lone pairs does not necessarily make it polar, because xenon tetrafluoride has 2 lone pairs, but because the molecule sets up this way with the 4 fluorines in a square plane and a lone pair above and below, these 2 bonds cancel, these 2 bonds cancel, they're linear to each other, that molecule's nonpolar. So you can't say that the presence of lone pairs makes it nonpolar, or makes it polar. It might not be. You can't say that if there are no lone pairs, it won't be polar. Because then if we take a molecule like this, and if I put carbon here, and I put a chlorine here, and I put 3 fluorines there, no lone pairs on the middle atom, but that chlorine is less electronegative than fluorine, that molecule is polar. So you have to look at each situation to make sure. Okay, I had a hand that flashed up and down real quick. Here. Yes. The dipole moment, right? Dipole moment's partial positive to partial negative. If you look at this down, so I'm going to draw the molecule, I'm looking straight through the axial position. So the equatorial position are fluorines like this and a lone pair, right? When we're looking at polarity, we're looking at bonds. Lone pair is not a bond, right? So this bond is polar in that direction, this bond is polar in that direction. You add those together, they add up to a dipole in that direction, pointing towards the fluorine end. The sulfur end is the more positive. So you don't look at, if you were thinking about the lone pairs over there, lone pair is not a bond. The lone pair is part of sulfur, okay? Sometimes in high school I've even seen where people come in there confused because people use lone pairs in predicting polarity. It's where the polar bonds are that predict the polarity. The lone pairs affect where those bonds are, but the lone pairs don't get counted into the the polarity calculation. Okay? Everybody good with this? Just a quick review showing you the kinds of things we can ask. And I'll point out that you need to be practicing this stuff, because if it takes you 30 seconds to come up with a formula, and then it takes you 3 minutes to draw a Lewis structure, that's pretty good timing. But then it takes you another minute and a half or so to figure out the geometry, and then you've got to think about hybridization. All of a sudden you're at 6 to 8 minutes for this one problem. You have to get good with these. Practice these so that you get up to game speed. You can't assume you can do this, and you have to be kind of paying attention to time. When you study, if time has not been an issue for you before, it will start becoming an issue for you. At some point in Gen Chem 1 or 2, you will start having problems with the amount of time we give you. And the solution to it is not for me to start taking problems off, but it's for you to start getting more efficient and learning, making sure you know what you're doing. Practice and drill on different problems like this. I've had questions about where do I get more structure so I can practice geometry, shape, and all that stuff. You just did a whole chapter 6 full of Lewis structures. Go back there, start from the formula again, draw a Lewis structure. Think about VSEPR theory with those. Predict polarity, predict hybridization with all of those structures you've already practiced or should have practiced. Okay? So lots of information. It'd be a great thing to do this weekend, I guess. Work on those, right? Okay. I spent a little more time on that than I was planning on, but I wanted to go through that with you and just kind of show you all of that put together. I think it's sometimes useful to see all those steps. Okay? Now, we then went on to start talking. We finished with this. You're running out the door.